Electrical conductivity of liquid. Electric conductivity is a property of any given material. Electric current can pass easily through metals like copper, aluminum, etc. Testing the material to know which allows electric current to pass through it. Take a LED, a dry cell, wooden sheet, 2 drawing pins, a safety pin and a piece of connecting wire. Now set up the electrical circuit. Place the safety pin in on position. The bulb begins to glow. Now replace the safety pin by a nail. The bulb glows. Now try with different types of materials instead of the nail, such as strip of paper, piece of chalk, a drinking straw, etc. and check whether the bulb glows or not. From the experiment, we conclude that some materials allow electric current to pass through them. When the liquid does not allow the current to pass through it, the circuit is incomplete and the LED does not glow. Similarly, some liquids are conductors of electricity and some are bad or poor conductors of electricity. When current flows through the object inserted in the gap, the bulb glows. Testing the electric conductivity of liquid. Take a LED, dry cell, metal pins, rubber cap of injection, bottles and wires. Now set up the electrical circuit. Note that the 2 metal pins passed through the cap should have a very small gap between them so that the pins are fairly closer but not touching each other. The LED should not glow when the pins are separated by the small distance. Now join the free ends of the pins together by pressing them for a moment and make sure that the LED glows. If release the pins, they get separated and LED should not glow. Now fill the rubber cap with different liquids like distilled water, drinking water, coconut oil, vegetable oil, kerosene, etc. one after the other and observe the LED glows or not. We may observe that the LED glows, but its brightness or intensity is not the same. Sometimes it may be brighter and sometimes it may be relatively dimmer, as it depends the flow of electric current through the circuit. Although a liquid may be a conductor, it may not allow current through it as easily as a metal does. Distilled water does not allow the electric current to pass. Water in its pure form is a bad conductor of electricity, but when water contains salts or acids, it allows passage of electric current and turns into a good conductor of electricity. Water in its pure form is a bad conductor of electricity, but the water we get from sources such as taps, hand pumps, wells and ponds contains some salts and minerals dissolved in it. These minerals are useful for our health. Water with salt is a good conductor of electricity and the current flowing through household electric appliances is very high. Therefore, we should never touch the electrical appliances with wet hands. Chemical effect of electric current. Let us take a potato. Cut it into 2 halves and take 1 half of it. Construct tester with LED bulb. Insert 2 copper wires of the tester into the potato, leaving some distance between them. Leave the inserted wire for 20 to 30 minutes. A greenish blue spot is seen on the potato around the wire connected to the positive terminal of the battery. But no such spot is seen around the other wire connected to the negative terminal. This greenish spot is due to the chemical change in the potato. Collect 2 injection bottles. Cut 2 5 cm long bits of thick copper wire. Use sandpaper to scrape about 1 cm of coating off both ends of the wire. Break open an exhausted dry cell and remove its outer metal covering. Cut 2 mm wide and 5 cm long strips from this zinc plate. Insert the copper wire and zinc strips into the rubber cap of the injection bottle. See that the copper wires and zinc strips do not touch each other. Now, take a wire and connect the copper wire of one bottle with the zinc plate of another bottle. Fill both bottles with diluted sulfuric acid. Carefully close the bottle with the caps in which the copper wire and zinc strips are inserted. Now our cell is ready. Take an LED. Attach 2 wires to its 2 terminals. Touch the wire from one terminal to the zinc plate and the wire from the other terminal to the copper wire. The LED glows. After a few seconds of immersion of zinc and copper wires into diluted sulfuric acid, zinc slowly begins to dissolve in the sulfuric acid as bubbles getting formed on the copper rod. The current is passed from the copper rod to zinc rod. These rods are known as electrolyte. The chemical energy is converted into electric energy by electrolysis method. Electroplating. When one metal is coated with another material, this process is known as electroplating. CuSO4 gives Cu plus 2 plus SO4 minus 2. Copper plating. Dissolve crystals of copper sulfate in pure water to prepare concentrated solution. Pour the solution in a beaker and add a few drops of diluted sulfuric acid to it. Tie one end of a connecting copper wire to the iron object to be coated with copper. Connect its other end to the negative terminal of a battery. Suspend the tired iron object into the copper sulfate. Suspend the copper plate into the copper sulfate from positive end of the battery through a switch. See that the key and plate do not touch each other. Put the switch on for 10 minutes. Switch the circuit off and take the iron key out. When electric current is passed through the copper sulfate solution, the copper sulfate dissociates into copper and sulfate ions. The free copper gets drawn to the electrode connected to the negative terminal of the battery and gets deposited on it. Thus, one metal is coated with another metal. Uses. Electroplating is widely used in industry for coating metal objects with a thin layer of different metals. Electroplating is done to repair worn-out parts of machinery. It is done for ornamentation and decoration purpose. Several articles made of copper or its alloys are coated with silver or gold. In general, the processed food items are preserved in tin-coated iron cans. Tin is less reactive to the wood than iron. When iron is coated with zinc metal, iron becomes more resistive to formation of rust. So, zinc-coated iron is used for bridges and in automobiles.
Welcome to the lesson on conductivity of liquids. At the end of the lesson, we will be able to check a tester to ensure that it is working properly. Use a tester to find good and bad liquid electric conductors. Know how to prepare a tester using a compass needle.
Don't touch the switch with your wet hand. You will get an electric shock.
But how, Mom?
Your hands are wet and water is a good conductor of electricity. So, you will get a shock.
Please explain it to me in detail. Why would this happen to me?
To understand this, let us do some activities. You know that a tester is an equipment used to test solid materials, that whether they conduct electricity or not. So, whenever we touch this tester to a simple electric circuit, the bulb will glow.
But the bulb is not glowing, Mom.
Yes, what are the possible reasons for this?
The possible reasons may be the tester is not working, the connections may be loose, the bulb is fused, or the cells are used up.
That is correct, Ravi.
Mom, I completed the checks. The connections were loose. Now we are ready with our circuit. The bulb is glowing now.
This proves that our tester is working. Take some normal water in a beaker and dip 2 wires from the end of the tester into the water. What do you observe?
The tester glows.
This means water allows the electric current to pass. Therefore, water is a good conductor of electricity.
Are there other liquids which are good conductor of electricity?
Change the liquid in beaker with lemon juice or vinegar and repeat the activity. You will find the tester glows. Hence, we can say that lemon juice and vinegar are also good conductors of electricity.
Can we also check the soap solution?
Yes, when we repeat this activity with the soap solution, the tester glows. Collect some rainwater in a beaker. When we repeat this activity, we find that the tester glows again. That means soap solution and rainwater are also good conductors of electricity. Liquids that allow electricity to pass are called good conductors of electricity. Solutions of acids, bases and salts are good conductors of electricity. But all the liquids are not good conductors of electricity.
How is that possible, Mom?
Some liquids, like distilled water, do not allow current to pass. So, they are bad conductors of electricity. Distilled water does not contain any minerals, salts or impurities. Hence, it does not conduct electricity. Liquids that do not allow electricity to pass are called bad conductors of electricity. In some situations, though liquid is conducting electricity, bulb may not glow.
How is that possible, Mom?
Actually, bulb starts glowing due to the heating effect of current. The filament of the bulb gets heated due to high temperature. If current is too weak, the bulb will not glow.
But then, how can we check conductivity of material with low current?
We can use LED instead of electric bulb in a tester. We can use magnetic needle deflection to find conductivity of material even though there is a weak current.
A magnetic needle deflection?
Yes, we can make a tester using the magnetic effects of currents. Take a tray of discarded matchbox. Place a small compass needle inside it. Wrap an electric wire a few times around the tray. If you connect the ends of the wire to a battery, you find that the compass needle shows deflection. Thus, our tester with 2 free ends of the wire is ready.
At the end of the lesson, we are able to check a tester to ensure that it is working properly. Use a tester to find good and bad liquid electric conductors. Know how to prepare a tester using a compass needle.
Good morning everyone. Today we are going to perform an experiment to test the conductivity of different liquid materials like tap water, distilled water, vinegar, petrol, mustard oil, lemon juice, kerosene oil, copper sulfate solution, iodine solution, milk and honey. With the help of this electric circuit, we will classify these materials as electrolytes and non-electrolytes. So the first liquid is tap water. Let's check. The bulb is glowing. That means tap water is good conductor of electricity. So keep it in electrolytes. So the next is distilled water. Let's check. The bulb is not glowing. That means distilled water is bad conductor of electricity. So let's keep it in non-electrolytes. So next liquid is vinegar. Let's check. The bulb is glowing. That means vinegar is good conductor of electricity. So keep it in electrolytes. Next liquid is petrol. So let's check. The bulb is not glowing. That means petrol is an non-electrolyte. So let's keep it in bad conductors. Next is mustard oil. Let's check. The bulb is not glowing. That means mustard oil is bad conductor of electricity. So keep it in non-electrolytes. Next is lemon juice. So let's check. Yes, the bulb is glowing. That means lemon juice is good conductor of electricity. So let's keep it in electrolytes. Next is kerosene oil. Let's check. No, the bulb is not glowing. That means kerosene oil is bad conductor of electricity. So let's keep it in non-electrolytes. Next is copper sulfate solution. So let's check. Yes, the bulb is glowing. That means copper sulfate solution is good conductor of electricity. So let's keep it in good conductors, electrolytes. Next is iodine solution. So let's check. Wow, the bulb is glowing. That means iodine solution is good conductor of electricity. So let's keep it in good conductors. Next is milk. So let's check. Wow, the bulb is glowing. That means milk is good conductor of electricity. So keep it in electrolytes. Next is honey. Yes, the bulb is glowing. That means honey is also good conductor of electricity. So let's keep it in conductors. So these are the bad conductors, non-electrolytes, and these are good conductor, means electrolytes.
Collect the materials such as LED, dry cell, metal pins, rubber cap of injection bottle, distilled water and connecting wires on the experimental table. Take the rubber cap. Insert the two metal pins vertically in the rubber cap. Make sure that the distance between two metal pins should be around 2 mm and the pins should not touch each other. Take a battery and a wire. Connect one end of wire to one metal pin and other end to battery negative terminal. Take another wire and connect its one end to the battery positive terminal and other end to the LED's longer terminal, that is positive terminal. Now take another wire and connect its one end to the LED's shorter terminal, that is negative terminal, and other end to remaining metal pin, and LED should not glow. Press the free ends of two metal pins so that they will come in contact with each other and LED glows. This acts as a tester to check the conductivity of liquids. Pour some distilled water in the rubber cap till the two metal pins are in contact with it. Now observe whether LED glows or not. Repeat the procedure with different liquids and tabulate the observations. When distilled water is used in the rubber cap, the LED does not glow. Similarly, when kerosene, sugar solution, honey are used, LED does not glow. But when drinking water, lemon juice or vinegar are used, the LED glows. We have learned that few liquids like drinking water, lemon juice, vinegar pass the electric current through them, whereas kerosene, sugar solution, honey does not pass the electric current through them. We also noticed that LED glows in few cases and does not glow in few cases. When the liquid allows the current to pass through it, the circuit is completed and it is called closed circuit and LED glows. Then we can say that the liquid is a good conductor. When liquid does not allow electric current, the circuit is incomplete, open circuit, and the LED does not glow. Then we can say that the liquid is a bad conductor.